Alright, so this is our final project for 410. What we're doing is we're taking 3 insulation cups, our 2 name brands, Yeti and Arctic, and 1 off-brand, Ozark, and we're going to be testing how long they can hold the temperature of different liquids. So right now, we got the test going, and the cups have ice cold water in them, so they should be running at about 32 degrees right now. And then after this test, we're going to be putting in some really warm water, about 212 degrees, and see how long they can hold that temperature. Right here is our running program. We have the DAC assistant inside a while loop, and we have the while loop running or getting data every 60,000 milliseconds, so that's every minute. And once the iterations hit 180, which will equal up to 3 hours, it's going to stop the process and record it into our right to measurement file. So the data is coming in to the DAC assistant, it's outputting it to this converter. The converter is going into the index array, and the index array is outputting 3 outputs. 3 means we wanted the mean to take the average out of the value so it can have a cleaner graph. And then right here is our calibration equation for the thermocouples, and it's coming into our channels. And with these channels, we can actually see what temperature it's reading right now. So if we go to the actual page, we can see that we've already started this program. We're about 17 minutes in, and channel 1 and 2 are the same because we only have 2 thermocouples right now. We will work with this one later. So we have one reading 31 degrees and the other one reading 32.7 degrees after 17 minutes. So we are recording the temperatures in a constant room temperature, about 64.9, 65 degrees, somewhere in between that range. All right, so for our second test, we have boiling water up to 212 temperature. We're gonna test her out. We're gonna do the Yeti versus the Ozark, and then we will do the test against the Arctic. We're gonna put about 5 to 6 scoops of the boiling water into the Yeti, and then we're gonna do the same thing to the good old Ozark cup. Alright, so we got the 2 thermocouples going into the insulation cups. It is about 65 degrees right now in the room. We started it off, and it looks like they were just at 193 and they already are going down. That's how quick the temperature is. And yeah. So right now we have our last test going. We got the cold water in the Yeti, and then we have boiling water in the Arctic. So here in the picture to the left of the screen shows our data that we have obtained from the LabVIEW program. On the left column we have the date and the time of when the test started, and then the 3 columns to the right of it are the data obtained from the thermocouples. So we have the Ozark, Yeti in the middle, and Arctic all the way in the right. Here on our graph, we have time in minutes on the x-axis, and then we have temperature in Fahrenheit on the y-axis. And from our data, that we can conclude that the Yeti was able to stay cold the longest for 180 minutes. We have the time and date on the first column, and on the 3 columns to the right, we have our hot data from the 3 cups. Yeti in the left-hand side, Ozark Trail in the middle, and Arctic on the right-hand side. And on the graph here, it's visually smoother than the cold graph. As you can tell, they all started around 195 and 194 degrees Fahrenheit, and in about 180 minutes they all went down to a little above 143 degrees. Yeti is again the clear winner here, as it was the hottest still at just above 150 degrees, while Arctic actually was in the bottom too.